Good morning. My name is James Little, and my company is Mass Spec Interpretation Services. Wiley has introduced new mass spec capabilities within their KnowItAll software. KnowItAll is a vendor-neutral data processing solution for spectral analyses. I have created a series of these training videos for the software, which can be found on my personal website. Today I will be sharing a presentation on the identification of unresolved components in GCMS peaks using KnowItAll. I will be demonstrating methods for doing unresolved peaks using demo file v50.cdf. As you can see below, it's a mixture of 48 components with 11 unresolved peaks. Several are co-eluding even. All need background correction, as you can see below, because there's significant chemical noise in the baseline. The techniques for unresolved peaks for components in GCMS spec analyses are shown below. The first is process it using leading or trailing edges of peaks with background subtraction. The second is a mix is directly searched with the standard similarity search using a subtraction view. The third is a 2-mixture, 3-mixture approaches unique to Wiley, which are very effective for IR because no chromatographic separation is employed, but are very useful even for GCMS analyses. A more standard reverse search will be demonstrated. And finally, deconvolution using MS Expert program will be briefly discussed and discussed in more detail in a later video. We'll use this peak that's around 28 minutes in the file, which is actually a mixture of two components that are co-eluding. The first being chlorobenzene and the other chlorobenzene D5. Today we will be using the Process It program, the Search It program, and the Mine It program. And I've discussed those in detail in previous videos, so some of that I will go through very quickly this time and slow down on some of the new information. So first we have to click Process It, go up to the top of the screen and say Open Data File. You'll notice this file that I'm interested in is pretty far down in the directory tree. It's all the way under KnowItAll Samples MS Expert. It's in that folder. And we'll open the V50 CDF file and open it. First, I will show you how to do a peak that's unresolved by doing a leading edge. So I'm going to right-click and do a box zoom mode just to make it bigger. And we're going to take the leading edge of this, hopefully to get no spectral interference from the peak on the back side. So we'll go down to the average range bar and do the leading edge of the peak. We'll go up to the background range bar and take a little background to get rid of some chemical noise. And in the bottom pane, we have our mass spectrum. We'll go up to Transfer to get it to the Search It program. Again, I've already set this up before the video started, and it will be, if you want to know how to set up all the parameters, you need to refer back to previous videos. But we will be doing a single search because we think it's a single component. You can see my mouse at the top of the screen here, and we'll go directly to search since everything's set up and do a search. And you can go to the bottom here, and you can see the top fit has a 96% plus HQI, hit quality index, and you can step through those with your mouse arrows going up and down. There's more than one spectrum of it, but it is this 1,2-dichloropropane. To show the next technique, I will need to go back to Process It. So go up to the top of the screen, and you could either click this arrow twice to get back to where you were at Process It, or you could just pull the little arrow here and go directly to Process It. Let's just go directly. What we'll need to do here is clean up this area, so we will first zoom out, and now we'll go to the trash can at the top to get rid of our background subtraction, and over at the right side we'll get rid of the average spectrum that we took. And now we'll move out to the peak at 28 minutes that we're interested in. So I'll right click again, get box zoom mode, box in on it a little bit, It looks like a symmetrical peak, but it's actually a mixture of the chlorobenzene and the D5 chlorobenzene. So we'll again get an average range. This time we'll do the whole peak with the average range bar. We'll go up and get a little background on the front side to take out. And let's just clean on the back side also. Let's just take some background on the back side also. In the bottom, you'll see that we have the spectrum that we're interested in from this range. Again, we go up to transfer to go to search it. Start a new search. It'll put it in a separate tab at the bottom of the screen here. We've got all the parameters set up before, so we can just go ahead and do a search. We're going to do, again, a single search, the number of components up here at the top. Go to the search and do it. If you look at the bottom, the first thing you'll note, if you step through a couple of these, I've highlighted the first one, that you only have a hit quality index of around 60%. So that should catch your eye and tell you that you probably have a mixture. So you can see at the top we have our mixture spectrum. We have the difference spectrum here, and we also have the best hitting spectrum, which is our chlorobenzene. So it's picked out one of the components. What we need to do now is send this different spectrum and search it again. So to do that, you don't want to be in the butterfly view. That doesn't work there. You have to be over here. I'm up at the top of the screen, say subtraction view. And that gives you this third spectrum to work with. We can now send any of these spectra we want back to search it again. So we're going up to transfer to search it. But it opens up this intermediate window. Here we'll have to get rid of the ones we don't want. So we'll get rid of the top one and the bottom one and collect the middle one. This is the one that had the residual peaks that we didn't know, or residual ions that we did not know what they were. And now we've selected the one we want, and we can say OK and say start a new search. Yes, we do. We'll create it in another box. The only thing that's a little strange here is that, see, it's brought the structure in for the first compound. If you do a search now and have that selected, it will not work properly. So you need to deselect that. We come up, and now we have our spectrum of the mass spectrum, and you can see this unknown, what's the residual left over from our search, we can send to the search again. So we'll come down and go to search, and you can see the best hit is chlorine D5. And you'll notice there's not much difference left over now, so that looks like the two components that are in our mixture. And you can see again that the hit quality index is still pretty high. It's 82%, not as high as the other one. But that's a good indication if you just look at the two spectra, top and bottom, that those are the two components in our mixture. Now we will demonstrate the third approach. So we will have to go back to process it again. So this time, instead of using the arrow, I'll just pull down the menu and say go directly to process it. We can use this same peak again because we just want to demonstrate another technique for doing this mixture. So all we have to do is send it, go up to transfer, and send it to search it again. Say start a new search. For the other search that we've done, the two that we've done so far, we use the single number of components. This time we will want to change to the mixture, so to mixture. And now we will send it again to mine it by doing the search. We've got all our parameters set up, so we come to the bottom of the screen and say search. It's going to take a long time to do this because it's comparing all the spectra of these 1.2 million compounds it's searching like it did before, but it has to do them both and compare and try to minimize what's left over after doing that process. So it takes anywhere from 30 to 40 seconds to do this search. So I'll probably just stop it for right now to save a little time and come back in when the search is over. The search is complete, and you can see up in the top right-hand corner that it thinks it's a mixture of chlorobenzene and this deuterated chlorobenzene as we expected. If we come down to the bottom and click on the first arrow, it'll show you at the top, it shows you the mixture spectrum. In the middle, it shows you the composite spectrum collected. But let's jump down to the first hit. It shows chlorobenzene. You show the mixture on the top. It shows the best hit on the bottom, which it thinks is chlorobenzene. In the middle is what's left over again. You go down, click on the next one, or use your mouse arrows to step to the next one. The next one shows you, again, the mixture on the top. Now shows you the deuterated chlorobenzene on the bottom. And of course, what's left over is the chlorinated benzene. The one that's really important, if you click down in the bottom again, is this residual spectrum. The residual spectrum is the difference if you take both of these and put it all back together, and this is what is left over, this third trace or this third pane below. If you have a lot left over then you need to go back and do a mixture 3 search, because it probably had too much residue, indicating that it was likely a mixture of 3 compounds. Now I will demonstrate the reverse search, the last manual search that we use. So we'll go up to the top, again pull down the arrow, go all the way back to process it. Here we'll use the same spectrum before, but in this case we'll go back to transfer, send it to search it once again. Here it brings up a different window because it knew that we did the mixture spectrum search last time, so it wants us to say start a new search, to open a new tab at the bottom of the screen and say OK. Again, we've got all the components set up. We need to go make sure we're doing a single search. So we're doing a single component and not a mixture 2 or mixture 3. But here we'll click reverse search in this box here to do a reverse search instead of the standard search, and go to the bottom of the screen and say search. This is somewhat different. If you go to the bottom, I'll click on it. You can see that now, even though we're doing a mixture, it says the reverse hit quality index is very high, 99.51. But if you look at the top here, this is our best fit that we've selected at the bottom. This is our mixture here, and this is what's left over. But let's just go back. Let's switch to the butterfly display. You can see that it really doesn't match very well because it didn't pick many ions. So that's it. What happens is that this hit quality index is not penalized for peaks that are present in the unknown that are not present in the known spectrum. So it just gives it, you don't get a penalty for any of these ions over here because it did find these ions here and it thinks it's a pretty good fit. But visually you can tell it's not a good fit, so we need to step through some of them. So I left clicked down in the bottom to highlight the box, and I'm going to use the arrow keys, the up and down on my keyboard, to step through them. Let's go to the second one. Again, not a good fit for much of the spectrum that we're interested in. We'll go to the next one. This one's starting to look a little promising. We've got the 112, the 114, the 77. That would make one think that this is one of the components, which it is. And what you could do here, you could go up to the top and go back to the display with the subtract, and you could send this residual spectrum back for another similarity search or reverse search, and you would find your second component. But you can see I don't find this one quite as straightforward as just directly searching it with the similarity search and then doing the different spectrum. But it is a way that you could do it if you like. Now, instead of a manual search, I want to show you an automated search that's new in the KnowItAll software. It's called MS Expert. So you come down to do that, you have to go to the function box on the side and go to Spectral Processing. Now you can find MS Expert and open it. It'll open another window here. Again, we have to go open our data file. We have to find it and then go and find v50.cdf. I'm going to open this, but I want to talk about it before I open it because it happens so quickly. What's going to happen, I'll open this spectrum or open this chromatogram. It'll go to the search. It's going to search every component in the mixture, all 48 of them. It's going to take out all background subtraction that it needs to get rid of the background. It's going to deconvolute overlapping or even co-eluding peaks and display the results. And this is going to happen probably around in 6 seconds to do all that I've said, search these 1.2 million for all this information for every component that it thinks it finds. And if I did this file manually to do the same thing, I think it would probably take me, if I had to estimate, 45 minutes to an hour and a half to do the same pre-analysis to get to some point to start making some conclusions. So we're ready to open it now. So we'll open it. It's going through and doing all the searches, and it's pretty much populated everything in around 6 seconds, which is really pretty amazing. And I won't go into this program in detail right now because I'm going to do a separate video on it. But let's talk about the main thing. If you come up to this right column up here and start clicking on the peaks, I've picked the first small peak. The first peak is a solvent peak of some type. And so I've selected it with the mouse. It's highlighted in blue. Now I can go to my arrows on my keyboard, the up and down, and step through them. What I'm looking at, if you come over here, you'll see these scores, 97.68. So it's finding things with high hit quality index. The hit quality index is 97.68 here. So we're just stepping through some of them because I want to show you something at a later point. And all these look very good. 99, 98, 99, 98, 90. Just all very good hits. The one that doesn't look good, the first one, is this peak at about 20 minutes. And it's 53. So that makes me think that the program hasn't done its job very well. And that would be a good candidate to take back for manual processing, as I showed you before. And we will do this, but step through the rest of them. All of them look good except that one. That's the only one that's a little suspect. So we'll go back and do manual processing. We need to remember which one that is. It's the peak right before 20 minutes. So we'll go back to process it to look at it. So we'll go back in to process it. Click the process it icon in the top left corner. Let's jump back there. We'll have to clean up a little bit here, so we'll right click to say zoom out. We'll go up to the trash can in our background range bar, get rid of that. Come down to our foreground, get rid of that. I'll use right click and say box zoom mode, and I'll go get this peak that the automated process had problems with. It thought it was a mixture of two components. There's just not something quite right about it. So what we'll do is we'll average over that peak using the average bar. And then we'll come and take a background subtract on the back side. Can't really take one on the front side because it might interfere with some of the peaks. So we'll just do one on the back side. And so on the bottom we have our spectrum that we think is probably a mixture of at least two components, and we'll take it to search it. So we'll come up to the transfer bar up here and say search it. Start a new search. Probably my favorite one for doing mixtures is to do the mixture search. It works very well. So I'm going to assume it's maybe a mixture of two. And again, when I do this search, it takes a good time to do it. So when I get it started, I'll just stop the video and come back in when it's done. So I'm going to the bottom, doing a mixture of two, and we'll do a search. Here are the results of the mixture of two analyses. You can see the best hit, the number 1, indicates that it's a mixture of these two components at the top. Let's take a closer look at the results. Let's come to the bottom and select the best hit. It only shows an 85% accountability of the peaks in the mixture spectrum. And also, if you look at the residual spectrum, there is some leftover signal that maybe we should consider. So we're going to assume that maybe this is a mixture of 3 or more components. So we'll go back and do a mix 3 analysis and see what results we get from it. So this time we only have to go back one level, back to search it. So we'll go up to the top left corner and push the previous application button. And now, instead of doing mixture of 2, we'll go to a mixture of 3 and start the search. And it will take a little bit of time to do this, so again I'll stop the video till the results are obtained. Here we have the results of the mixture of 3 analyses. If you look up in the right corner, you'll see it proposes to be a mixture of 3 components now. Let's go look at the numerical results and the residual. We go to the bottom, click the left mouse button, and you can see now instead of around 85% of the countability, we have closer to 98%. Also, we'll go down and look at the residual spectrum and see that there is very little left here. So things are looking more encouraging here. Let's go down a little further. Let's go ahead and look at the second hit and see what it proposes. Again, around 98%. Here you'll see it's the same two components on the right, but it's also proposed that it could be another isomer of this dichloropropene. Let's even go down and look at the third hit. I'm scrolling down this time to jump to the third hit. Again, about 97%, still pretty close. But in this case, it's proposed yet another isomer of dichloropropene. So from these results, I would say that the peak that MS Expert was having trouble evaluating is likely a mixture of the two components on the right plus some isomer of dichloropropene. So in conclusion, if you're looking at a file that you suspect is a mixture of unresolved peaks, I would always start with MS Expert and do deconvolution first. It's a very efficient process compared to the manual ones. However, if problems are noted in the MS Expert result review, use the manual approaches below. The first manual approach, and the easiest, is to take the spectrum on the front or trailing edge and process it if possible. If that's not possible, my go-to type method would either be the mixture 2 or the mixture 3 search function. My next choice would be to do the regular similarity search using subtraction and searching different spectra or spectrum to get the results. And my last choice would be the reverse search using subtraction and searching different spectrum. So be sure to look at my other video, and particularly the one on MS Expert that talks about in detail how to use the program, but also look at some of the other training videos that I've made on KnowItAll. Good day.